Hey there, it's Jason Gorman from Codemanship with a video about continuous integration and continuous delivery for JavaScript teams. And teams is the operative word there. This is very much a team activity. Now, you may have heard those terms. You may even think that you're doing continuous integration or continuous delivery, but let's see, shall we? A lot of teams claim to be doing what we call continuous integration and what they call continuous integration, but they're actually continuously merging their changes into a separate branch, a developer branch or a feature branch, and then less frequently, maybe every few days or so sometimes, or once a week, merging those changes from that branch into the main branch, or the trunk as we like to call it. By definition, that is not continuous integration. The purpose of continuous integration is to merge our changes in with everyone else's changes on a frequent or continuous basis for a number of reasons. First of all, so that we can check that our changes work with other people's changes, so there are no merge conflicts waiting for us. Teams that merge infrequently, for example, teams who work on feature branches, tend to find themselves stuck in what we call merge hell whenever it comes time to merge their many changes into the main branch, into the trunk, because there are often lots of conflicts. The smaller the batch size, the fewer the conflicts, the easier they are to fix, the quicker and more painless the process is. So we integrate continuously so that we can test that our changes don't conflict with other people's changes. We also want to make our changes available for release on an ongoing basis as well. This is where we come into continuous delivery. This is another term that's often used and often misunderstood. Many teams claim to be doing it and they are also not, usually again because of branches. Continuous delivery means that our software is continuously shippable. It's always shippable. That means it's always in a state where it could be shipped. If your changes are sitting on a feature branch or a developer branch for days at a time, that is not shippable code, and therefore you are not doing continuous delivery. Businesses want the benefits of continuous delivery. They want to be able to just press a button at any time and have the changes when they need them or when they're ready. And therefore the code needs to be in a shippable state, which means it needs to be sitting on the main branch, on the trunk, and very importantly, it needs to be working. It needs to not be broken. So continuous integration means frequently checking in our changes to the same branch as the other developers on the team, not to our own branch. And continuous delivery means that the software is always shippable, which means that it's in version control on the branch from which we can then create a release build and deploy that into the production environment. Now, we'll talk a bit later about the benefits of continuous delivery and therefore the need for continuous integration, but it'd probably be easier to have this conversation by demonstrating with a little example. So what I've got here is I've got a little project that I'm working on, and imagine there are two versions of me. There's Jason 1 and Jason 2. And this is for a CD warehouse. Jason 1, hello, has been working on the requirement for buying a CD, and you'll see they've got a bunch of tests there. And he's got an implementation of a buy function there that passes all of the tests. And at the moment, this is just sitting on my laptop here, not in the trunk. It's not in the main branch. So to make this shippable, it needs to somehow get in there. Jason number 2, hello, is working on a different use case. He's working on searching the catalog for CDs. Again, I've got a bunch of code here that is not in the main branch. It could not be shipped, and therefore I want to somehow get it in there. So we're both at a stage now where we've written some tests, we've got some working functionality, and we would like to share that with the rest of the team. We'd like to get that into the trunk, into the main branch. Now, what is the process we need to go through in order to do that so that whatever's sitting on trunk is always shippable, in other words, always works? How do we do this without breaking the code? So this is all about avoiding, first of all, avoiding checking in code that doesn't work. And you'd be amazed how many developers still do that, but also avoiding any merge conflicts with changes that other developers on the team have been making. So let's start with Jason 1. There's my code there. And Jason 1 is thinking about checking in this code. Now, Here's the danger between JSON1 and JSON2, and this danger grows as the team grows or as we integrate more frequently. First of all, before I think about checking in, I need to make sure that my changes work with everyone else's changes. So what I'm going to do is I'm going to do a git pull to get any changes that other people might have made, or to at least check that I'm up to date. Then I'm going to merge any changes that have been made into my code locally, and then I'm going to run the test and see them pass locally before I then commit and then push that to the trunk. But before I do any of that, the risk is that while I'm merging changes and running tests and etc., JSON number 2, hello, is also checking in, and he checks in changes after I've pulled and merged that I no longer know about. So how do we prevent developers from checking in on top of each other with conflicting changes like that? Well, think of your source repository as a database, which is exactly what it is. It's a database with multiple concurrent clients, each of which are committing transactions to that database concurrently on top of each other, potentially. Now, if it was a database, how do we stop clients of a database concurrently updating the same record with conflicting changes? Well, we can use a lock, and we can do a similar thing in a more kind of low-tech way, maybe, when it comes to using version control. So teams who are co-located, often they will have what's called a build token or a build lock. And this is some very recognizable object, big enough to be seen from across the room, that sits in a shared space on a shelf, for example, where everyone can see it. And in order to check in, you have to go get that build token or build lock. And that prevents other people from checking in on top of each other. So let's lock the repository. Here's my build lock, my build token. It's a hat. Hats are very popular, big hats, because you can put the hat on and then people can see from across the room, JSON number 1 there, hello, is checking in. So I'll have to wait until he's done. But number 1, lock the repository. If you're working online or working remotely, you can probably find some way of doing this, for example, using Slack or something like that. So it's not a difficult thing to do. And particularly as your team gets larger and people are integrating more frequently, the risks of those kind of conflicting check-ins grow. So you do need to think about this stuff. So I have locked our GitHub repository. For this, you will need a GitHub repository. I will post a link to the repository in the comments, in the description below. So I've got my GitHub repository. We've both got clones of that we're working on. And what I'm going to do first of all, oh, that's the wrong one. That's JSON number 2. I'm JSON number 1. It can get very confusing when your team is made up entirely of you working on the same laptop. First of all, let's check and see what has changed. What have other people checked in? So let's pull. And we are up to date. So that's good news. There's nothing to merge. If there was something, I would need to merge that first. And then make sure that all of your tests are passing with everyone else's changes merged into your local code. So that's looking good. So let's commit this. So I've added YCD function test. Looking good so far. And what else did I do? I deleted a dummy test. So we'll talk a little bit about build automation in a second. Now it's time to share this with the team. Confident that what I've got here actually works. So when I check it in, it should work. So I've called this shared branch trunk. We don't call our branches master anymore. Off it goes. Now there you go. I've pushed, I've checked, and so I can take the hat off, right? I'm done. Or am I? Well, there's more to think about now. I need to get what's called a corroborated build. So I need to rule out the possibility that the only reason it's working is because it's on my laptop, some local configuration that's different to the release machines, for example. And there we go. We've got a green build, a successful build. So what that build is doing is it's checking out the code and building it if necessary. That's not necessary because we're in JavaScript and Node. It's then running all the tests using Node, using npm. Then we at the end can see whether or not it actually works on someone else's machine. If you've ever heard yourself saying, well, it worked on my machine, well, this is how we avoid that possibility. Don't just see it work on your machine, see it build and see the tests pass on another machine. This is a cloud-based build server. So we can take a look at what Cloud CI is doing here. It's one of my favorites. So it's spinning up an environment. I think it's using Docker. So it's spinning up an environment to run this, this Node application in, setting it all up. Then it checks out the code from our repository from the trunk branch. And then it runs some npm tasks. So it installs any dependencies that it needs that we've got specified in our project there. And then finally there, we can see that it's running the tests, and we can just double check, is it really running the tests? Yeah, you can sometimes get a little blind to this, but it looks like it's all working, but it turns out it's not actually running the tests, or something else has gone wrong. So just double check when you start setting up your builds that it really is running the tests, and it really is. So there you go. At that point, as a developer, I'm kind of done, and I can take off my hat and put that back for other people to use, which means that JSON number 2 now can think about checking in. Now, here's the thing. If you're working on a team and other people are contributing to the same code base, it's important to become build aware, that you should always be keeping one eye on the build status. So if you've got some kind of way of visibly displaying what the status of the build is, so that you can see, a lot of teams have build monitors that might have big TVs that show when builds are happening or when they're succeeding on one, and so on and so forth. Keep one eye on that, because that's a form of communication between the team. What it says is, check it out, man, something's changed. So we do need to be thinking on a fairly frequent basis. You don't have to do it immediately, but on a regular basis, just even if you're not thinking about checking in, maybe consider pulling those changes and seeing what has changed, so you're getting a heads up on what's actually changing. In this case, I am thinking about checking in. So JSON number 2, I'm going to go get the build token, put on the hat. That means that JSON number 1 can no longer check in now. And now that I've got the hat in, the first thing I do is check to see what has changed. And in this case, we know there are changes. There we go. A bunch of stuff has changed. No merged conflicts. That's good news. If there are merged conflicts, well, you know what GitHub will do. If you're familiar with it, what Git will do, it'll create a sort of a merged file, if you like, and you'll need to then go in and resolve all of those conflicts yourself. And once all those merges are done, the next thing we do is we make sure that our changes work with JSON number 1's changes. So let's run our tests. We can just do that. And while we're at it, let's just take a little sneaky peek. What has JSON number 1 been doing? Oh, okay. So, his CD has got a price and a stock level. But my CD there, that's interesting. It's got an artist and a title, but no price and no stock level. So that's something that maybe JSON number 1 and JSON number 2 can go grab a coffee and have a chat about at some point. The emerging design of this CD object. Okay, now I've got a bit of gubbins to do, so I need to add some stuff. Okay, and now that it's working, we can commit that. So I added search. And so there's a couple of new files in there. And now again, it's my turn to think about pushing this to the trunk. Oops. Off it goes. And again, while it's doing that, we need to go take a look at the build status. So there's a Git hook in there, basically, that when there's a new commit that gets pushed, it will automatically run a build on it. Now, while we're waiting for this build to happen, one thing we're going to talk about in a future video is how long the builds take. That's kind of a critical thing for the speed of your feedback loops, the speed of your delivery cycle. The longer the build takes, the slower that cycle is going to be. And what I've seen with many teams is when the builds are slow, everything else is slow. It slows everything down. The build speed is a bit like the metabolism of your team. And as your code base grows, tends to be that the lion's share of the build time is how long it takes to run the test. So if your tests take half an hour to run or an hour to run, you're going to find that that's become a slow metabolism for everything else that's happening on the team. And you'd be very surprised what problems mysteriously go away when your build cycles are very fast. So in the next video, we're going to talk about the testing pyramid and how we optimize our tests to make sure that they run fast so that we can have fast running build cycles and get those fast feedback loops. Okay, so our build has succeeded, which means that Jason number 2 can now take off his hat. And around we go. And that's kind of the process there. So the goal here is to make sure that our changes on as frequent a basis as we can are being shared with the rest of the team so that we can test that there are no merge conflicts. And so that, very importantly, those changes can be made available to the business whenever they want to release them. And that's very, very important. And because that enables fast business feedback cycles. So companies that are very good at continuous delivery and all the technical stuff that comes with it, like fast running unit testing and continuous integration and all that wonderful good stuff, they tend to find that they can get feedback. They can learn very, very quickly from very frequent releases. Teams that have very slow delivery cycles tend to find that they learn much slower. And in this modern age of digital, we tend to find that the companies that succeed are the ones who outlearn the competition. So those fast feedback cycles are definitely very important. And that's why all of these technical practices that contribute to continuous delivery are so very, very important. Okay, so that's continuous integration and continuous delivery, or is it? Now, I do a 1-hour exercise on our Codecraft training workshop called Evil Fizzbuzz. And it's a bit like this. We take a group of people, maybe there's 10 or 12 people, and we split them up into pairs. And then I give each pair part of a problem to solve. So they've got to write some code that's part of an overall program, one single program, but they've each got to do their own little bit, and they're only allowed to write their code for their part. So they set up a GitHub repository for it, and they all get their clones, and they all set themselves up as contributors. They set up build automation. That the shaving those yaks often takes quite a lot of the hour. And they get all that up and running finally, and then they start pushing code. But the reason that most groups fail at Evil Fizzbuzz and fail at continuous delivery is because they forget the most important part of the delivery pipeline. I start the exercise by waving this machine at them. This is the customer's production environment. It's an old, low-powered PC of mine. It's got some dev stuff on it, but it's quite old. It's quite low-powered. And I say, by the end of this hour, you need to demonstrate your Fizzbuzz program working on this machine. You need to deploy it to this machine and demonstrate it on here. So if they're a team that works in Node, for example, I need to see that Node program running on here. And always, 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 they leave that part to the last minute. Here's some advice. Start here. How are we going to get it onto the machine? What's on the machine? It's amazing. It's a 1-hour exercise, 50 minutes in, people are saying, oh, has that machine got Java installed on it? What version of Java? Start there. So don't start writing your program and doing your whatever your domain is or your use cases are. Start with Hello World. Get Hello World through that pipeline. So from someone's desktop into GitHub to a build server, and then via that or via GitHub, depending on how you want to do it, deployed onto here so that you can run it on here. Now this actually has Node on it, which means that they could just, for example, send me a Windows batch file. It's Windows 8, by the way, a Windows batch file, and I can run that, and that will check the code out and set up the environment that way very simply, and then run their program using Node at a simple command line, very easy. Then I can see it at the command line, and that passes the test. That's Evil Fizzbuzz. But they don't start there. They start with code. No. It's the wrong way around. As with test-driven development, the idea is to start with the outcome that you want and work your way backwards. So the development pipeline, the delivery pipeline you need is the pipeline that puts that working program into the customer's hands. That's the goal there. So start there. So we probably beyond the scope to actually demonstrate that now, but you could very easily with Node just check some code out and demonstrate it using Node on here. The other mistake that often teams make is they make their tech stack too complicated. So one team, for example, immediately started setting up Docker, it didn't go very well for them either. So the secret to evil fizzbuzz, well, there are several secrets to evil fizzbuzz. Secret number one is start with the outcome. Start with the customer's production environment and get Hello World deployed to that via your delivery pipeline, and only the delivery pipeline you need to get it to here. And secret number two is coordination. And continuous integration, trunk-based development, is all about team coordination. Who's checking in now? What's changed? Should I pull? Blah, blah, blah. So it's one of the mechanisms by which teams synchronize with each other, literally, in the concurrent sense of the word. That's how we synchronize with each other. And if your synchronization is infrequent, you're going to have synchronization problems. You're going to have merge hell. If your synchronization is frequent, you're going to have a lot less problems. And there's going to be a lot more communication within the team about how the code is evolving and how it's changing. For example, what is the schema of a CD object? It can't be one or the other. It must be both, potentially. So have those conversations early about how the architecture, for example, is evolving. Continuous integration can really help. Think of it as a form of communication among the team. But a lot of teams really underestimate just how much communication and coordination is required. So when I sit there and I watch teams in the room attempting evil fizzbuzz in their little pairs, I can pretty much predict the ones who go off into their corners and don't talk to each other for the first 45 minutes will fail. It takes a lot of coordination and a lot of communication. The third thing that really helps, and this is very important, if we take a look at this code again. So I was working on two modules, buy and buy test. Oh yeah, by the way, something's changed. So Jason number one should think about pulling those changes. Let's pull those changes. No merge conflicts. And the reason there are no merge conflicts is because we're working on separate files, and there are no, at the moment, there are no overlapping concerns between my code, Jason 1, and Jason 2's code. So the better the separation of concerns, the easier it is for people to work in parallel, the less conflicts you're going to get. So there's one tip. If you're doing evil fizzbuzz, can you figure out a way to do it so that as much as possible, each part is independent of the rest of it? And there are ways of doing that. And the final tip, the final way that it goes wrong, is that teams essentially are undisciplined about all of these technical things. Either they didn't write any tests and didn't realize they'd broken it, or they weren't running the tests as often as they should be, or before they check in, or they were checking in on top of each other. Because one of the rules of evil fizzbuzz is, and you could see that I did it earlier, one of the rules is if you break the build, then the exercise is over, you've failed. It is an exercise in trunk-based development, in not breaking the build. So if you break the build, so you have to be super, super disciplined about your check-ins, which is why you need to think about how you control access to the repository at the same time. Now, I'm just going to finish on two final related topics. First of all, you see our red build there, our build failed, because it failed to find the tests. Silly Jason. Now, what happens if the build fails? What happens if someone on the team breaks the build? The usual response is, well, it's their responsibility. They have to fix it. But if we're being disciplined about this, what can't we do if you're on a team and someone's broken the build? What can't I do until that build is fixed, until it's green again? I can't check in. I am now blocked. The delivery pipeline is blocked and nobody else can deliver. So really, it's everybody's problem. It's a blocker for the team. In which case, it might not need the whole team to sort it out, but it is definitely an issue for the whole team. So it needs to be resolved with some urgency. And you've got a couple of choices here. You can fix it quickly, fix it and get it up and running. But if you can't, you should basically just roll it back, revert to the previous working version, so that, yeah, one person's going to have to redo some stuff and they're going to have to start again, but the rest of the team is now unblocked. And if you've been continuously integrating, you're not going to lose a lot of work. There's not going to be too much stuff to redo there, maybe an hour's worth or something like that. So It's a discipline. It's a real discipline. It's a very important discipline. It is the discipline that enables continuous delivery, and continuous delivery is what enables those fast business feedback loops that businesses can then use to outlearn the competition. So it's something that a lot of businesses want. And I've seen some big businesses essentially brought to their knees by their inability to do this for all sorts of reasons. In the next video, we'll talk about one of the biggest blockers, which is how long the tests take to run. The final thing I just wanted to mention is there may be people sitting out there thinking, well, Jason, the reason we use feature branches is because we don't want to release unfinished features, just for the same reason that you don't want people driving down half-finished bridges. You don't want users clicking on things that aren't finished yet. But there is a way that we can have our cake here. We can have the benefits of continuous integration and continuous delivery, and we can hide features that are unfinished. And I'm just going to quickly demonstrate here. It's called a feature flag, and I'm going to create a little text file here. How you do it is up to you. A simple way to do it would just be with a simple text file. So we could call that, for example, features.txt. And we could have, let's say, for example, search equals off because it's not finished yet. Buy equals off. Maybe let's say that buy is now finished, it's ready. So let's switch that on. So we would have a list of features in a very simple data file like this, and we could switch them on and off, or we could even have our customer cut the ribbon, as it were, on each feature so they can switch them on and off as they see fit. And then you would have something very simple built into your architecture for the user interface, for example, that shows features that are switched on and hides features that are switched off, just makes them visible or invisible. And you could rig up a similar thing for APIs. So if people try to use an API for something that's not finished yet, then you could have something built in. There's a design pattern there for web services, for example, called front controller. So you might have lots of different entry points for your API, but they could all be going through the same HTTP filter that just checks the feature flags and goes, no, that's switched off, and then returns an error and says, not ready, sorry, or whatever. So this is a very simple way, and a way also that we can put customers in the driving seat if we're a bit more sophisticated about it, that allows us to hide features that aren't finished, but still gives us the benefits of continuously integrating our changes with other people's changes so that we can test for merge conflicts and that kind of good stuff. So there you go. That's continuous integration and continuous delivery. It is very much a team sport. There's an individual element to it in terms of the dance that we have to do when we're checking in, but really the only way to get the hang of this stuff is to practice as a team. So I recommend that teams do continuous integration and continuous delivery drills like Evil Fizzbuzz. So from a standing start with just the machines you've got, how quickly can you get a delivery pipeline up and running and get into that whole trunk-based development thing? And also that discipline of not breaking the build. Very, very important.